welcome to our latest episode on the Denodo Data Bytes series. This is your host Neha, and we are thrilled to welcome our guest this week, Kevin Bohan, who is the Director of Product Marketing for the North America region at Denodo. Kevin is a leader within the product marketing space with extensive experience in defining and executing global go-to-market strategies. Welcome to our show, Kevin. Totally looking forward to our discussion today on effectively leveraging a logical data management platform to unite disparate data sources, reducing data sourcing and preparation time with data science. But before we begin, can you give us a quick introduction in terms of your interest in the tech space as well as your role at Denodo?
Hi, and thank you for having me. So just briefly, as far as my interest in the data technology industry, my real passion comes from working with customers to help them identify solutions to challenges they might be facing. I started my career as a customer service rep in the call center, then moved out to working with customers, helping them deploy it inside of their environment. And the real pleasure for me comes when I'm able to help customers understand and identify solutions to challenges they might have. As far as my role inside of Denodo, I am, as you mentioned, the Director of Product Marketing. So as part of that, what I do is I lead the positioning and messaging for Denodo, including the content that would appear on the website or other collateral that we create. And all of that, again, trying to help customers identify how they can address challenges they might be facing.
Perfect. Thanks for the introduction there, Kevin. So, moving on to our first question on today's discussion. So, we've heard a lot about artificial intelligence and machine learning these days. So, let's start by setting the context for the discussion today. What are some challenges that data scientists face when it comes to data?
Sure. So I guess there's a number of different challenges that data scientists face. There's a whole bunch of different studies out, and the numbers come back a little bit different, but something that's clear in just about every one of them is more than half of the time that data scientists spend is on data preparation, getting the data organized, clean, and ready for analysis. So you're taking these highly skilled individuals, resources that are quite often hard to find and bring into the organization, and having them spend time on finding the data, making sure the data is in the right format, and all of that. So that's certainly a big challenge. If you can make these individuals more effective by reducing that time, you're going to get a lot more value out of them. You don't necessarily have to recruit as many, which are, as I mentioned, is also very difficult. Another thing that I see quite often is a lot of initiatives within organizations when they talk about their data and analytics focuses on SQL-based processes. And SQL is great. And don't get me wrong, I'm not knocking SQL, but SQL, when it comes to machine learning, is probably best suited for batch mode of when you're training your models. But I think what you need to do is for when you're actually using the models, the inference portion of machine learning, streaming technologies are critical. Because what it does is it provides a continuous stream of information, which means then the models are able to, in real time, give you back predictions. And SQL's not necessarily ideal for that scenario. So I think that organizations are still catching up in that area. I think that's an important aspect to some areas that we can improve to help things. The other part is around data enrichment. Well, some might be picking up on and adopting the streaming technologies. What you're also looking to do quite often is there's only a certain set of information that's available when the data is streaming in real time. And what you want to be able to do is enrich that, add perhaps context about where the customer is located or other information you might have in other data sources you want to combine, but also do that in real time. So again, you're able to feed back predictions to the organization in real time, allowing you to be more competitive in how you respond or what next best action you take. So I think that those are some of the big challenges that data scientists face.
Thank you for sharing that. So discussing this a little bit more. So what are some ways to improve data science initiatives? What steps can be taken to maximize the value organizations get out of their AI initiatives?
Sure. So I touched upon it in my last response was, I guess, a bit more on the technical side of things. I'll take this one a little bit higher level. There's two schools of thought or camps that people are falling into now as it comes to data science. Gartner defines them as model-driven AI and data-driven AI. The concept of the thought process behind the model-driven is, what steps can we take to better train the models? What new models can we use that might give us better outcomes? The second, and the data-driven, the concept there is our models are really good these days. We also then have tools to help create new models like AutoML and things like that that can test what models are going to work best for this type of data. And the premise then for the data-driven is you shouldn't necessarily have to focus as much on the model now. You're going to get more value out of your initiatives if you focused on improving the data that's being fed into the model. So, sort of, I guess, going back to the old analogy of adage of garbage in, garbage out. If you don't have high quality data being fed into the models, then the output of the models aren't going to be that good. So that second camp is saying, if we focus more on improving the data, we're going to get more out of the models. So I don't necessarily think it's an either or. But I do believe that there is strong validity in that second approach of improving the data is going to probably yield better results these days because the models are pretty good these days. So improving that data is going to give you the best bang for the buck.
That's an interesting approach, actually. So you're saying out of the two, there's no right or wrong answer, obviously, but these are just two different approaches that you would suggest, and the second one it's probably more relevant according to you.
And it also, of course, it depends on your organization. No two organizations are the same, but in general, what I have seen, because the models keep on getting better and better, that really the weakest link in the chain these days is the data that's being fed into the models.
Perfect. So moving forward, what are some data trends you see that are improving how data scientists find and access this data that you're talking about?
Sure. I think that let's take a step back before we talk about like some of the trends. What's some of the challenges? Why is it so hard for the data scientists to find the right information, to have that information in the right format? Part of the challenge comes from this distributed nature of data. So most organizations have many, many data silos. You have information tied up in your ERP system. You have information tied up in your CRM system. You have proprietary databases running on premise, some others running in the cloud. You're adopting SaaS services to fill specific needs within HR departments. The list goes on and on. We have these different data silos. The information's in different formats. And a traditional approach would say, let's replicate that information, move it to a central repository, and get it into a common format. Then we can make use of it, or what they would call ETL. More recently, they switched it around a little, get it into a common repository, a data lake, and then we'll do ELT. We'll do the transformation on the back end to transform it into the specific needs you have. But all of that, one, takes time. And with AI models, you want to be more real time and drive these things in real time. But also what you're looking for is a way to more easily access the data from more users. And what we see as a trend is this logical approach to data management. If you think about it, the very definition of a data fabric talks about the bringing together distributed data silos or distributed data sources without necessarily having to do that replication. So it in itself, data fabric is a logical approach to data management. But also another popular trend these days is the data mesh, which is managing your data in a distributed way. And if you think about what they refer to as data products, that's really, again, the abstracting of data. So what we see is this logical approach to data management is gaining traction because of the different values that I spoke about and how it simplifies things for the end user. a popular way that people go about that is a capability called data virtualization. Forrester recently did a study, Forrester Total Economic Impact of Data Virtualization. And what they found is you are able to deliver data sets, deliver new data sources 65% faster than ETL approaches by using data virtualization. What they also identified is it took 67% less data preparation by data scientists than the traditional approach of ETL. These are significant savings. A third of the effort for data scientists, if you're using a logical approach or virtual approach to data management, which is a big improvement. If you're able to eliminate that amount of time for the data scientists, and it's majority of the time they're spending on their tasks, you're getting significantly more value out of each of the individuals you have working on these processes. So we see that as a big trend, this logical approach to how people are managing their data and how they're delivering that data to the end users, whether it's a data scientist, a business analyst, or whoever else in the organization might need that information.
Wow, that is really interesting to know that, like there was this different approach of data silos and, like the traditional approach rather, where data was being moved to the central repository. But the logical approach towards data management now basically brings together these silos without the need of the central repository, right?
Exactly. And the reality is, we have to face it, this isn't a new approach. ETL has been being done for probably over 30 years now. I'm not aware of any organization that centralized all of their data into one location. So it's not necessarily even happening in reality. So once we embrace that data is going to remain distributed and we figure a new way to manage it, a new way to make it easy for end users to access, that's when we're really going to start getting the value out of the information that we need.
Correct. That makes sense. My next question for you is, can you share what are some required capabilities that an organization needs to deliver this logical data management approach for their data scientists, or rather any other data consumers for that matter?
Sure. So the first part is the whole essence of what I was describing. So it's the ability to create this centralized data access layer that presents the information to the users in a format that's familiar to them. So what do I mean by that? It's creating what they call a semantic model for the data. So if I'm presenting information to the data scientists or to somebody in the sales department, you might present that information in a very different format because they're going to consume the information differently. But you also don't want to necessarily present it to them in the same way the schema was built within the database, because they have abstract names that don't make much sense. And but being able to customize the views for the different consumers, yet not necessarily replicating the data each time you do that, is one of the key benefits. And what this allows you to do is you can have different layers or different tiers where you can bring together and make a canonical view of the data, and then you can customize it for a particular use case, or you can allow the user to customize it for themselves. So that's a big part. And there's something I mentioned earlier about not only providing it in a SQL access method, but also providing it in other means. So supporting APIs like REST APIs or GraphQL, which are becoming more and more popular, GraphQL, but also streaming modes like technologies like Kafka, JMS, and other popular streaming modes. These are all important ways to provide the data to the end user. The other important piece, it's one thing to be able to deliver the data to the user, but if the user doesn't know they need the data, doesn't know that they want to request that information, it's not very helpful. So a technology that's also very popular now is data catalogs. And data catalogs maintain information about all of the available data that's accessible by the users. It'll define what's the data source, what information's in it, definitions, glossaries, all of those types of important facts. But what I like to recommend to users is think of it as a little bit more than just the data catalog. There's terminology that people use, and they refer to it as a data marketplace. And why I like this is it changes our thinking a little bit around providing that view of the data that we're going to describe what the data is, to thinking of that full life cycle of getting the information to the end user. So a data marketplace has all the same capabilities of the data catalog, but it also combines that data delivery capability with the catalog. By doing this, you're able to not only define within the catalog what some of your data governance policies are, what your security policies are, but since you're also providing the delivery aspects, you can add the enforcement of those policies as well for the end users. By providing other capabilities within inside of this interface for people to come and explore and discover the different data that's available to them, you can adopt other methodologies or concepts that are common in a marketplace, like recommendations from other users. If I see a peer of mine uses that data source and they say this is a good data source, I'm going to have greater confidence in it. If I can ask questions of the data owner, if I can think of all of those things that you have available to you when you go shopping on Amazon, so you get the confidence that I'm going to make this purchase, or I'm going to get that product they're offering. Provide that same experience to the end users. It makes a big difference because a product is a lot more than what's in the box. It's also all of those extra things that you're delivering to them. A definition of what the product is, its usefulness, how long it's valid for. The data might expire after a certain amount of time, won't be as valid. All of those things are what makes up the why you have faith in products you're buying online. It'll help the end users as well. Another part that's important, I mentioned, we have different users and you might want to present information in different ways. You also want a key part of getting value out of the data is reuse. So you don't want to customize it too much so it's only for a specific use case. But what you can do with inside of the marketplace is give those tools to the end user so they can do that, what they call last mile transformation, and allow the users to tweak and customize those things, easy things that they can do to have it specifically usable for their use case. But you also provided something common enough where it's reusable and you're getting that true value out of the creating reusable packages of data that could be used by many within the company. When you start doing that and you have those collaborative capabilities built in the platform, I think it's when you start getting the real value out of what you're looking for.
These were some great inputs indeed. So moving forward, we've discussed the various concepts of effectively leveraging a logical data management platform for data science as methodologies. But can you tell us how companies put these concepts into practice though, in terms of customer stories that reflect the need and benefit of data science with a logical data management platform?
There's so many. So let me think of a good one. I guess one example is Prologis. For those who aren't familiar with Prologis, they're the world's leading logistical warehouse space provider. And what I mean by that is, these large transportation and logistics companies don't necessarily build out their own warehouses. When they need additional space, they can go to Prologis and rent out warehouse space. Just to give you a perspective of how big they are, I think the number is they have about 800 million square foot of logistical warehousing space that they provide to their customers in over 19 countries. So they're a massive organization as far as providing space for different retailers, transportation logistics companies, and all of that. And what they had is they had what I think most organizations have, the traditional on-premise data warehouse, and it couldn't scale to meet the demands of the business. So what they did is they adopted Snowflake to be able to scale their data infrastructure. Snowflake, as you know, is well known for separating compute and storage, allow you to dynamically scale and all of that. But what they did is they added the Denodo capabilities. So now that the data was inside of the Snowflake environment, what they were able to do is leverage the Denodo platform to add that logical access layer atop what was in Snowflake, as well as again, like as I mentioned earlier, not everything goes into this central location. So they had other sources that were still on-prem or other SaaS applications, the ERP system and that. And by using Denodo, they were able to create this abstraction layer of all of the information within inside of Snowflake and all of their other data sources. And the consumers only had one location to go and find well-curated data for them. Additionally, they implemented and leveraged the Denodo data catalog to make it easy for the end users to explore, discover, and access new data sources. By doing this, they've estimated that they accelerate the workload for their data scientists by over 30%. So by their estimates, on average, each data scientist was able to accelerate how quickly they could create new models, how quickly they could bring new data science models to the business 30% quicker. So it was a significant benefit for them. So that's one example. But as I said, this is a very common use case for what people are using the Denodo platform for. So there's many others, but I think that's a good example.
This was a great example indeed. So before we wrap this up, I have a short Q&A session. So are you ready for this?
Sure.
Awesome. So very quickly, so what is a favorite summer or winter sport that you would like to choose?
Sure. So I guess if you asked me a number of years ago, it would have been focused around things that I like to do. But I'm a parent of four, so I find myself on most weekends on the side of fields, and I really enjoy watching the kids and the sports they play. So I have a daughter that's very into running. She's a distance runner, so cross country, track and field, both winter and spring. I have two boys that play baseball. My older one, now she's in university, but she used to play soccer and also track and field. So my time these days, and when it revolves around sports, is watching the kids play sports, and it's probably more enjoyable than when I played, just because you get great joy in seeing your kids do well. I think more so than even when you did it yourself. So that's where I spend my time as it relates to sports.
Definitely. Wow, that sounds wonderful. So great answer there. And tell us about a motivating factor that helps you succeed in your role.
That's an interesting one. I guess really I'm going to probably equate it back to the work ethic that I learned from my parents. I come from a large family. I'm the youngest of 8, and my parents always were working very hard to be able to not only provide for us from bringing income in and revenue like that, but also just having to deal with, I mean, now I have 4. I can't imagine having double the number of children. So they are always hard workers, and it instilled in me hard work and what success can come from it, working hard. And I think that really what, for me, drives me to do a good job in each thing I'm working on, and also helps me be successful in what I'm doing.
Wonderful. Thank you so much for such a fun session today, Kevin, and for taking the time to talk to us about data science and all that it entails.
Thank you for having me. It was a fun time. Maybe you'll have me back sometime.
Thank you. And a quick message to our listeners: if you've enjoyed this episode, please head over to www.denodo.com/podcast to find out more resources on all things data.